Hi there, this is Mr. Ambrose's video for AP Calculus class on Tuesday. In this video, what I intend to do is introduce to you the next topic we will cover after parametric equations. And this next topic is polar coordinates. Now, polar coordinates is not the fashion style that you would find if you actually go up into the Arctic. Instead, polar coordinates is just another way to express points that we have in our xy coordinate plane. Now, unfortunately, this unit can sometimes be challenging for students. And one of the reasons why it sometimes is challenging because there is a decent amount of trigonometry involved with this particular unit. So the first thing I'd like to do with you guys is to review with you guys your exact values and some angles. So here is the chart of exact values that you definitely would want to have memorized. In terms of how to perhaps be able to memorize this particular chart, we normally start off with the first row being sine, and every single exact value is over 2, and the numerators essentially increase by 1 starting at 1. So it's just 1, 2, 3 in those numerators. And each of them pretty much you can think of as being underneath a square root, especially since the square root of 1 is equal to 1. Cosine is second because it is essentially the reverse order of the sine function's exact values. And then tangent is last. You can think of, or if you recall, tangent is equal to sine over cosine. And so, for example, at 45 degrees, since both sine and cosine are exactly the same, that's why the tangent of 45 degrees is equal to 1. To memorize your exact values of your quadrantal angles, meaning like 0 degrees, 90 degrees, 180 degrees, and so on, we usually refer to the unit circle to help us with getting those exact values. We know that for any point that's on the unit circle, x, y, we can express that particular point by the cosine of theta, sine theta. So if perhaps we want to know what the cosine of 180 degrees is, we go to that point on the unit circle and we see the x-coordinate there is -1, and that's why the cosine of 180 is equal to -1. So you'll definitely want to have this particular unit circle memorized to help get the remaining exact values that you'll need to know for this particular unit on polar coordinates. As we know in calculus, the desired angle measure that we use will always be in radian measure. So here is a particular diagram of the unit circle with our angles that we frequently use with exact values, and you'll notice that there are degree measures at each respective spot along with their actual radian measure. We know that if we want to convert from degrees into radian measure, we just need to multiply by pi over 180, and going from radian measure into degrees, we can just multiply by the reciprocal 180 over pi. But being familiar with these particular angle measures will definitely be helpful in this unit. Now, all your mathematical career, when you've worked in the xy plane, you've been essentially using what we call rectangular coordinates, x, y. It's called rectangular coordinates because if, for example, if you have the point A, B, you know exactly where that point is located by essentially going out A units on the x-axis and then B units on the y-axis. And thus we can find the exact point, and when we do that, we, in essence, form a rectangle. And that's why those particular points are what we call rectangular coordinates. But for various reasons, sometimes we prefer to get to our points in a more smooth fashion, and that's why in particular we have what we call polar coordinates. So polar coordinates are just another way to express a point that will be placed in the xy plane. So here we see an example of a polar coordinate. The point P, it has coordinates r, comma, theta. The r represents the particular distance that we need to travel always from the origin out to that respective point. The angle theta is going to be very similar to how you understood theta with trigonometry and how you use that to rotate around the origin. So in this case, since we rotate counterclockwise a particular angle to get up to that terminal side of this particular radius, that's our angle theta. And as with trigonometry, when you rotate counterclockwise, you will always have a positive angle, but when you rotate clockwise, you will always have a negative angle. Now, with this polar coordinate, you should be aware that r is really, or should be considered as, a directed distance from the origin out to the point P, because in certain cases r can actually be negative. The negative almost tells a direction in which to actually go out from the origin. So when you want to go and plot a point that has a negative r value, you would first perhaps want to plot the point that would be the positive r value, comma, theta, and then reflect through the origin to get the desired point. And we'll see an example of how to actually do this. Okay, so now let's look at some examples of plotting polar coordinates. Here, in the first example, want to plot the polar coordinate that is 2, 3 pi over 4. Now remember, with polar coordinates, the first coordinate is r, which is basically almost like a radius value. So, in the xy coordinate plane, to help with plotting this particular point, what I'll draw for myself is a little circle centered at the origin with a radius of 2. And then I know that my point has to lie somewhere on this particular circle. But to find out exactly where it's located, I now look at my angle. The angle that's given here is 3 pi over 4 radians. And polar coordinates, the angle will always be in a radian mode. If necessary to help plot this point, you would want to convert this over to degrees. And in degrees, this would be equivalent to 135 degrees. So knowing that this is equivalent to 135 degrees, I know that that particular point would take me into, or that particular angle would take me into the second quadrant, and so approximately over here in the second quadrant would be where our polar coordinate would lie. Next example is the polar coordinate 1, negative 5 pi over 3. So once again, on my xy coordinate plane, I draw out a circle centered at the origin with a radius of 1, and then I look to my angle to figure out where on this circle the actual point will lie. Negative 5 pi over 3 is equivalent to negative 300 degrees. Now, just to be careful, it is negative 300 degrees, so recall that when you have a negative angle, we rotate actually clockwise, so this particular angle will actually end up landing in the first quadrant. So the point would lie approximately there in the first quadrant. In this example, the polar coordinate now is negative 3, 5 pi over 6. Now I would once again start with the radius. In this example it is a negative number, so we'll have to make an adjustment, but I know that because the r value is negative 3, that the point will be a distance of 3 units away from the origin. So I would still draw my circle centered at the origin, now with the radius of 3, but what I'm going to now go and plot is the point that would be positive 3, 5 pi over 6 first. And so for that particular point, the angle measure of 5 pi over 6, well, that's equivalent to 150 degrees. So this particular point would actually lie in the second quadrant, approximately over there. And to finally get our answer to the original problem, all we do now is we take this point that we just plotted and we essentially reflect that through the origin. So the final answer would actually lie in the fourth quadrant, approximately over here. This point over here in the fourth quadrant would be -3, 5 pi over 6. So this concludes this particular video on polar coordinates. This hopefully gave you a little introduction to what this will involve. In class on Tuesday, you'll just be given a gift that will just practice plotting some points. And then on Wednesday, remember, one of the periods I will allow you to ask questions regarding your parametrics test, and then the other period will continue to just further look at polar coordinates. Hope you have an awesome day. Take care.